Okay, and finally in part 4, we're going to explore 2 specific types of logarithms. So it just so happens that logarithms that have a base 10 are called the common logarithm. So the common logarithm is a log with a base 10 on it. So in general, we do not write that base 10. So that would be just written as log of x. So in other words, if you see no base, that tells us that the base is 10. This is the one that's built into your calculator. So your calculator automatically has a log base 10 into it. So when you see log on your calculator, it's a base 10 logarithm. So we just want to make sure that you can evaluate these on your calculator. So example 6 says to evaluate each logarithm to 4 decimal places using a calculator. And it says log of 327.1. So literally on my calculator, I'm going to type in the log key or hit the log key. Then we'll type in 327.1, and then you'll hit the equal sign for enter. If you do that, you get 2.5147. I want to point out with just this one that you can check this really quickly to make sure you understand what's going on. So when no base is written, we know the base is 10. If I take 10 and raise it to the 2.5147 power, my answer will be approximately 327. So you can check it. Okay, part B says we have the log of 529,000. So I expect something fairly large as my answer because this would be 10 raised to some power is 529,000. Well, that's got to be a fairly large number. And sure enough, you get 5.7230. For part C, it asks us for the log of a decimal, 0.0237. So again, remember, you can plug in any number you want as long as it's greater than 0. So I can plug in decimals. I can also plug in a radical, right? So we've seen that. So this is saying 10 to some power is equal to this. Well, in order to get into how are we going to get a decimal out of that? So 10 to some power is equal to that decimal. Well, this means what you're doing is doing 1 over 10 to some power. So we know that the answer is going to be negative. And sure enough, you get a negative 1.625. And I don't have the next decimal, but I'll let you go. So the negative makes sense on it. You're going to get a negative anytime the argument is less than 1. And finally, part D says, what about the log of 10 raised to the 3.6729 power? What? Okay, so go ahead and look at the answer. So you type that in, and you're going to find out the answer is 3.6729. That should make sense. This is saying that 10 to this power is equal to 10 to that power. So sure enough, and don't forget that the logarithm and the exponent are undoing each other. So this is why we're getting the exponent as the answer. We'll do a lot more with this in the next section when we talk about log properties. So that's the common logarithm. It's a log with base 10. The common logarithm, you use it pretty much regularly in the sciences. The Richter scale that we measure earthquakes with is a common log scale. The pH scale in chemistry is a common log scale. How we measure sound intensity, the loudness of sound is a decibel, which is a log base 10 scale. So common logarithms are used a lot. In the biology end of the world, and also in the business end of the world, we use something called a natural logarithm. It occurs in nature, hence the term natural logarithm. And it's a log with a base of e. But because we already have common logs written with no base at all, we need some special notation for a log with a base e. So what we use is we abbreviate natural logarithm with an L and an N. I will tend to use a script LN because otherwise it looks like 1N or IN or something. So I tend to use cursive when I'm using the natural logarithm. So if you see an LN, it simply means a log with base E. It is also written on your calculator. On your calculator, it's an uppercase L and an N, but it's also there. So that's a log with base E, and you do need to know that. So in example 7, we're going to evaluate several of those. So we have ln of 0.9632. So again, because this is less than 1, we're expecting a negative. So if you hit ln on your calculator, type in this decimal, you're going to get a negative 0.0375. So e raised to this negative power is equal to this. So again, you can check them and make sure they make some sense to you. Then natural log of 183.1. So e raised to some power is 183, and that power would be 5.210. Part C says the natural log of e raised to the 1.3862. Well, this is saying that e raised to some power is going to be e to this power. So we know that this answer is going to be 1.3862. Again, by this point in this section, you should be automatically switching things in your mind to exponential form so that they do make sense to you. And there it is. So there's the natural logarithm. And then finally, in example 8, we're just going to do a quick application problem. The tail end of everything in this section. It says a population of mites in a laboratory is growing according to the function defined by P of t is equal to 80. Now it says log base 10, but in general, we won't write that base in there, but for now we will, just for this section. And then we're going to see of t plus 10, where t is the number of days, so t is days, and p is the number of mites. So it's the population of mites in my laboratory. So they're going to ask me a couple questions. They want to know, first of all, find the number of mites at the beginning of the study. So how many mites did I put into my little aquarium or beaker or whatever when we started? So we're going to find p of 0. So that would be 80 log base 10 of 0 plus 10. That would be 80 log base 10 of 10. And if you go to your calculator and do log of 10, you're going to see that it's equal to 1. That would be 80 times 1. Wait, does that make sense to you, right? If that's equal to x, then 10 to the x equals 10. So yeah, it equals 1. So we get 80 times 1, which is 80. So in the beginning, you had 80 mites in your beaker. Okay, well, what about after 90 days? So how many mites did you have after 90 days? P of 90. So that would be 80 times the log base 10 of 90 plus 10. Well, 90 plus 10 is 100. So now we're taking the log of 100. And if you take the log of 100 on your calculator, you're going to get 2. Now, does that make sense to you? Well, yeah, 10 squared is equal to 100. So we should get a 2 out of that. And 80 times 2 comes out to be 160 mites. I didn't need my calculator. And we'll talk a lot more about log properties in the very next section. The very next section sets us up in order to solve equations in the section after that. So the log properties are really, really important to understand. And you've got now a good solid groundwork on what a logarithm is. Remember that exponential functions and logarithmic functions are inverses of each other. So you can undo them by doing the opposite or the inverse function. Thank you.